All right, folks, this is the Radio Shack Science Fair microcomputer trainer. Has a binary LED output. It's got a hex LED output, audio speaker out, amplifier circuit, central processing unit, command codes and subroutines, basically your opcodes and relevant relevant subroutines are right there on the panel. You got a typical keypad, which is really just some very, very elementary switches. And what's really interesting is, and I've seen some other people do this on YouTube, the keypads can be, if you wanted to hook this up to an Arduino or something like that, or I've seen people do it with anything that's got a GPIO, you could enter your programs, using another, just by manipulating the connections with a GPIO on, say, an Arduino. Again, a career in, let me get this right. Let's see. A career in computer technology can begin with us. Science Fair computer trainer. Look, I'm telling you, people, I've used this. This is it comes with a decent manual. It has plenty of programs to practice. It's handy little machine. It is cardboard. Obviously cost engineered, very cheap construction. Wouldn't stand up well if it was held in an area with moisture or anything like that. But this particular one, here's the back, is in decent condition. Oh, and you can't see it, but there's 6 batteries right there, and it runs off 6 batteries. It runs off 9 volts, which I think is interesting. All right, so we have our opcodes. There's 15 opcodes. There's 15 subroutines that are built into the monitor. You have to remember that this is a 4-bit computer, so your output, it's appropriate to have a 1-digit output in hex, and because it's 4-bit, you also notice that 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6. You don't see the full 8 bits there because these are all the addresses, and it doesn't address any higher. It doesn't need a 7th binary LED to address beyond. It doesn't have it doesn't go that high. So this is going to be your address bus, and this is going to be excuse me, and this is going to be an output for you. So anyway, let's power it on, and I'm going to write a quick blink sketch program, and using the provided, I made Xerox copies of the sketch sheets, so in order to run a blink on this thing, and I've practiced this before, so but we're going to load the Y with a 1, and that's 2 bytes, and then we're going to load the A accumulator with a 1, that's 2 bytes, and then we're going to load A with an F, and I'll explain that in a minute. And then we're going to call a subroutine called set R, which is going to set it's going to turn on the digit that we select, the one that's selected by the Y register. And then we're going to call a timing a timer subroutine that will basically is the length of that time is set by the value of the A register. And then we're going to call a a reset subroutine that's going to turn off the LED that was indicated by the Y register. And right now we're not making any. We've loaded the Y and the A registers, and we're not going to change them. And so we've got call set, call timer, call reset. We're going to call timer again, and then we're going to jump. And see, each one of these call set, they're all 2 bytes. Jump is 3 bytes. So and jump to 0, 0. No, we're not going to go to 0, 0. We're going to go back to 0, 4. Let's see what happens. So LDY with a 1 is, they call LDY they call, what I call load Y register, they have transfer into Y, TIY. So let's just, okay, so that's an A, and then we have a 1 in there. LDA, they call that transfer into A, so that is an 8, and we were putting an F in there, right? Okay. Call, which is kind of a jump subroutine, but is always an E, and the subroutine set R is E1, and then call timer is E Charlie, and then reset is E2. Call timer, we already know, is E Charlie. And then we're going to jump, which is F 0, 4. Now let's see if this is going to be right. Loading accumulator with A, loading the accumulator with 1, loading the Y accumulator with 1, loading the loading the Y register with 1, loading the A accumulator with an F, jump to subroutine, jump to a subroutine, jump to a subroutine, jump to a subroutine, and then jump back. So that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 commands. So let's go ahead and hit the reset button and enter this. So we are at address 0. Look, nothing's lit up. So let's hit an A, increment. Now we're at address 1. 1, increment. And then 8, just like we compiled it, remember. 8, increment. And we wanted to put an F in that. And then E for the jump subroutine, E1. And then we wanted to go EC, which is go to the timer. And then E2 for reset. And then the timer again. And then we're at we're command number 12. So we're going to jump. So now it's an F, and then we're going to 0. We're jumping back to 4, right? All right. Okay, let's do a reset, and let's look at what we wrote in here. Increment. All right. Load Y with a 1. Load the A with an F. Jump to subroutine 1, which is the set. Jump to subroutine Charlie, which is the wait. Jump to subroutine 2, which is reset. Jump to subroutine Charlie, which is the wait. And then F, which is jump to 0, 4. End of program. Reset. Run. Look at that. Blinking. Just like we asked. Okay, so I'll make a couple changes here real quick. Okay, reset. So we loaded the Y register with a 1, right? And that's what did number 1. So let's load the Y register with a 5 instead. Okay, so A, which was load Y, we're going to change that 1 to a 5. And then we're going to reset, run. And now look, 5 is blinking. Okay, so you have a blink sketch where, so anyway, you can select which one you want to blink. You could, you could increment Y between blinks and have it move over. Who knows? All right. Or let's do this. Hold down reset. And remember, we loaded the A with the A registered with F. That set the duration of the timing subroutine. So let's go to a. So we're going to change byte number 3 from an F. I'm going to change that to 2. And what do you know? It's blinking faster. All right, so this little training manual is very good. I wish they had taken the. It's a little too late to change it. I mean, it's only been 30 years, but I wish they would have treated I wish they would have given us the commands, in 2 ways. The way that they've done it, where they're walking you through very slowly, and also where maybe they had like a data sheet type layout where it would just give you the all the commands and their functions as well. But so it makes it a little harder. But it does teach you. Well, hold on. The first part of the book is after getting it assembled. And then they go through a little bit about block diagrams and stuff like that, which I think most people glazed over. And then it went straight into dumb stuff like electronic organ, playing Swanee River. I mean, just turn it into like a little organ in where you're just, but I guess that's a start. And then it gets better. But it actually starts walking you through different commands. It's teaching people the flowchart. It's teaching people machine language in on a 4-bit machine, which is really, it's actually an 8-bit MCU, but it's emulating. I wanted to say virtualized, but it's not. It's emulating a it's got a virtual 4-bit machine. So that's what we're programming. It's the virtual 4-bit machine that's on that 8-bit MCU. So anyway, it's got some pretty clever, for a 4-bit machine, it's got some very clever programming techniques in here. There's a good one in here that I was flipping through that would takes a section of memory and sorts it according to size, which is interesting. And again, there's games. So there you go. This is the Radio Shack Science Fair microcomputer trainer. It is an excellent training tool to teach basically the fundamentals of machine language, literally. All right, so I've been playing with this a little longer. I was having a trouble with the jump command, or with my commands. The program wasn't working, and then I realized that in order to do a jump, the jump command might fail if a flag is set, if a carry flag is set. So what you have to do is there's no op instruction, and there's no busy instruction where you could do anything, and there's no clear carry flag or anything like that. So what I had to do was run a command called change, which is exchange A for B, and then change again, which so the A register and B register were switched, and then ran it again. That flipped them right back again. So that would clear any flags, because it was just exchanged registers and re-exchanged them, and no flags would be set doing that. So I made my program a little more complicated, and and I compiled it already by hand because it's pretty easy. But we're gonna load the Y register with a 0. I refuse to use their their version of the commands. I'm used to saying load Y, not transfer into Y. Okay, so load Y with an A. Load Y with a 0. Load the accumulator with a 5. All right, so those are basically your setup, right? Okay, we're not going back to those. And then so we're going to call set R, and then we're going to call the wait, and then we're going to call the reset after the wait, and then what we're going to do is we're going to add to Y 1, and then so we're going to increase the Y register by 1, and then we're going to do this flip A for B, and then we're going to flip it again, so A becomes B, and then B becomes A, so it's back to normal, and then the jump command isn't going to fail because it's not seeing a flag that's forcing it to fail. So then I'm going to jump back to 4. So let's power this baby up again. Come on. Reset. And A, increment, 0, increment, 8, 5, echo, 1, echo, 6, and then jump again, echo, back to 2, then I'm going to add Y to B, which is add 1 to Y, which the command is B1, and then I'm going to do the flip, and then I'm going to flip back. Then I can jump, which is F204. Reset. Okay. Let's follow along. Okay, address 0, got an A, which is we've learned all along is load the Y with a 0. Now we're loading the A with a 5. Address 4, watch these counting up in binary. E is jump to subroutine 1, which is the set register. It sets the binary LEDs, and then we're gonna jump to 6. No. E Charlie. And then we're going to jump again to 2, which is the reset. And now we're going to add to Y 1. We could add 2 and make it skip. Okay. And then we're doing we're exchanging A and B registers, and we're exchanging B and A registers again, and now we're jumping back to 4. Reset, 1, run. Let's see what happens. Okay, here we go. So, and what happened is it just ran off. Let's see, reset. Okay. And basically I think it's counting up to 15, but doesn't do any good to count up to 15 when you've only got 7 of these. So what we could also do is do a compare. Is wrap it around to 0 again. Okay, and we could do a compare to whatever digit this is, which is digit number 6. We can compare it to 6 and stop, or we could just let it wrap around all the time like that. Let's do this. One other thing I want to show you. When you add, go back to increment. So we have A0, and then there's okay, 85E, E, okay, B. This is where we're adding to the Y register. So instead of adding a 1, we're going to add an F. Okay, what does that do? Is basically it's the same as subtracting a 1 because there's only 15. A nibble can only be 0 through f. So if you add f to say 1, you're going to get 0, and so you're going. And then if you add f to 0, you're going to get f, and then if you add f to f, you're going to I don't know. Anyway, it's the same as subtracting. So let's just do this. We're going to put an f in here, increment, okay, and then we're going to reset, run, and it should count backwards. Okay, so now it's at 15, 14, 13, 12, and here it comes. There it goes, running backwards. So there we go. Pretty cool. All right.